Today we'll be looking at parametric differentiation. Okay, differentiation. So let's start by understanding what parametric equations are. Okay, unlike functions where y it's expressed directly in terms of x, where we find y is equals to x. Parametric equations define both x and y in terms of a third variable, usually t. We'll be using mostly t. Okay. This parameter it allows us to describe more complex curves such as circle, ellipses, and other interesting shapes. Okay. Let's look at example of parametric equations. Example, no? We have x it's equal to cos of t and y equal to sine of t. These are example of like parametric equations because we have t as the parameter. Yeah? Okay. We have t as the parameter. You see, we're expressing x and y in terms of t. That's why we are using parametric differentiation. Okay. Let's look at maybe an example. Let's look at a simple example so we can understand what this is. Okay. Let's see. They say find dy over dx. Okay. For a set of parametric equations where y is equal to sine of t and sine of t and x equal to cos of t. The question says find dy over dx for set of parametric equations where y is equals to sine of t and x equals to cos of t. So how do we do parametric differentiation? Okay, so because there is a third variable that is introduced, the first one will be dy over dt. Dt because the third variable that is introduced is t, so we say dy over dt it's equal to, then we derive sine of t. Okay, what is the derivative of sine of t? We know basically that derivative of sine of t is equal to cos of t. Okay, you are done with the first one. Then now we go to x. This means we have to say dx over dt it's equal to, what is the derivative of cos of t? We know derivative of cos of t is equal to negative sine of t. Understood? And then we continue. Last thing that we must do now is to find dy over dx, because they said find dy over dx. Yeah. So how can we find dy over dx if we have dy over dt and dx over dt? Yeah. We know that dy over dx will be equal to dy over dt over dx over dt. Okay. This means that on top we'll have dy over dt, which is cos of t. And below we'll have dx over dt, which is equal to negative sine of t. Yeah? The last thing that you must do now is to simplify the equation so you can find your dy over dx in its simplest form. Okay. So how can we simplify cos t over negative sine of t? We know that sine over cos is equal to tan. Okay, so what will be cos over sine? This will be equal to negative cot of t. Okay, so this is your dy over dx. Understood? Okay. Let's do another question. Okay, let's find a more complicated question so that we can understand how the concept of parametric equations work. Okay, on number 2, they say find d squared y over dx squared. Okay? If y is equal to ln into sine of t and x is equal to cosecant of t. Okay. Now they are not saying find dy over dx. They are saying find d squared y over dx squared, the second derivative, okay, of these parametric equations. Okay. So the first thing, before we go to the second derivative, we have to find the first derivative. Then how do we find the first derivative? We have to first derive y in terms of t. We derive x in terms of t. Okay. So dy over dt will be equal to, what is the derivative of ln into sine of t? We know the derivative of ln into something is 1 over that something. Okay, multiply by derivative of that something. Okay, this is what I mean. This means that our derivative will be 1 over something. It's ln into something. This means we'll have 1 over the inside, which is sine of t, multiply by derivative of the inside, meaning derivative of sine of t. No, derivative of sine t is equal to cos of t. Okay, and then now we just have to simplify. So this is equal to cos of t over sine of t. It's equal to cot of t. So meaning with our dy over the t, it's equal to cot of t. Okay, and then now we'll go to x. So what is dx over dt? Okay, what is the derivative of cosecant of t? Okay, so what is the derivative of cosecant of t? We know derivative of cosecant of t is equal to negative cosecant of t multiplied by cot of t. From tables of derivatives, okay, you just have to cram this one. Derivative of cosecant of t is negative cosecant of t multiplied by cot of t. Okay, and then the last thing to do is to find dy over dx. Oh, okay. So what will be our dy over dx? You know, dy over dx is equal to dy over dt over dx over dt. And then dy over dt is equal to what? It's equal to cot of t. Okay, over what is dx over dt? It's negative cosecant of t multiplied by cot of t. Okay, then now we simplify. We cancel cot t with cot t. We are left with dy over dx, which is equal to 1 over negative cosecant of t. Okay, so how can we further simplify cosecant of t. We know that cosecant of t is equal to 1 over sine of t. Okay, so what will be 1 over cosecant of t? This will be equal to sine of t. Okay, just have to substitute it now. Okay, this means that our final dy over dx, our final, okay, this means our final dy over dx will be negative sine of t. Okay, this is your final dy over dx. Okay, so the question, it didn't say find dy over dx. It said find d squared y over dx squared. The second derivative, not the first derivative. So how do we continue from that? Okay, we know that to find the second derivative, d squared y over dx squared, it's equal to d dt of dy over dt. Oh, sorry. It's d dt, it's equal to d squared y over dx squared is equal to d dt of dy over dx over dx over dt. That is your formula for finding d squared y over dx squared. It's equal to d over dt of dy over dx over dx over dt. Okay. Then now we put our variable. So d over dt, what is our dy over dx? It's negative sine of t over what is dx over dt? We go and check. Our dx over dt is equal to negative cosecant of t multiplied by cot t. This means we'll have negative cosecant of t multiplied by cot of t. And then the last step is to simplify and find your d squared y over dx squared. So d squared y over dx squared is equal to d over dt, the derivative of sine t. What is the derivative of sine t? We know derivative of sine t, it's what? It's cos of t. But because we have the negative, it will be negative cos of t over negative cosecant of t multiplied by cot of t. Okay, then now cancel the negative. Okay, and then we further simplify this. Okay, so this will be equal to cos of t over what is cosecant of t? Equal to 1 over sine of t multiplied by what is cot of t? It's cos t over sine of t. Okay, this is equal to cos of t over cos of t over sine squared of t. Okay, and then we further simplify. We know that this will be equal to cos of t over 1 multiplied by sine squared of t over cos of t. Then now we cancel this and this. And then we'll find that our d squared y over dx squared is equal to sine squared of t. Okay? That is your final answer. So the first thing that we do is to find dy over dx. And then from dy over dx, we use the formula d squared y over dx squared is equal to d over the t into dy over dx over dx over dt. And then you simplify, you find your answer. Thank you.